Okay, the problem is rotating the box. So what they have said here, they said like one m cross n matrix is given, name as box grid, and representing the side view of the box. Each cell has any of the followings, like if it is a hash, then it is actually a stone and it is movable. Stationary obstacle, as an name is stationary, it cannot move, it is kind of fixed position. And this is marked as star. And one is the empty one. Like if the box is empty, then that's why it is an empty one. So what we have to do? We have to rotate the box 90 degrees. So assume this is the box. So if I rotate the box 90 degree, then let's read the problem first. Then we'll see what will happen. So rotate the 90 degree. So some stones will fail due to the gravity. Each stone will fail until it lands on a obstacle or another stone or at the bottom of the boxes. So gravity doesn't affect the obstacle. So obstacle is kind of defies Newton rules or defines the gravity, defies the gravity. It doesn't, gravity can't have that power to affect the obstacle. I don't know what kind of obstacle that are, but it is what it is. So the inertia of the box doesn't rotate, doesn't affect the horizontal position of the stone. I will explain this, what this means. So and this in this, it is guaranteed that each stone box grid rests on the obstacle or another stone or the bottom of the boxes. See what are they mean one by one. First, they are saying rotate the clockwise degree. Okay, so rotate it. So if I rotate this thing, let's see. Let's take a copy of it first and rotate it. Okay, it will not. It should not come there. That is here. It should come here. Yeah. Now I have to just simply rotate the box. This is rotation. So after the rotation, it looks like this, right? It looks like this. Now the gravity comes in the picture. What the gravity will do? Gravity will simply, for this gravity, this ball or stone, whatever it is, will come to the bottom. So that is, it is meaning here. Like first, after rotating 90 degree of the clockwise, what I have did already, causing some stones fall due to the gravity. So that is what it is happening right now. The stones are falling. Okay, stones are falling. So each stone falls down until it lands on a obstacle or another stone or the bottom. In this case, this stone here, it has come down to here. So in the bottom. So now what will happen? Now this stone will also comes down here, like here. It will landing on the stone. So this is the case. It is saying. So it will either lands on an obstacle or another stone or the bottom. So obstacle, I am coming to obstacle in the next example. So this is my obstacle. Okay. This is my obstacle. Is also take the image slightly here. So what actually, so before going there, this is my output actually. This is my output. So I have to return this array. So they have given us this grid, fast grid, and I have to return this grid. So what will happen after gravity shows his attitude or something, his deeds, we can say. So okay, jokes apart. So let's understand the problem here. So this is the thing. This is the obstacle. Okay, this is the obstacle, and it doesn't, like, gravity can't touch it. Gravity can't touch it. Gravity has useless on this for this obstacle. So what will happen if I just simply rotate the box? So it comes here, and if I rotate, it will looks like this, right? So gravity for this, that what is called this obstacle will not fall, because as it says like here, gravity doesn't affect the obstacle's position, and I'm coming inertia later. Okay, obstacle position. So that is means, and so what will happen? So this ball will fall, but it will fall until it hits the lands on the vertical obstacle. That is the mean in the first line. It lands on the obstacle. Okay. So inertia and this thing guaranteed part I'm giving one example. So this will be the final output. Okay. So this is the case. Okay, let's take another example. This is example one. Example one. This is example two. Let's take another example and understand what this inertia means. Example three. Okay. So let me take two box. I'm not going to run. Not this. Copy, just copy. Paste it here. Okay, another paste. Okay, let's understand two cases. What does it mean? First, assume like fasting is inertia doesn't affect the box. So what I means this, if I remove this one, so if I right now rotate this box, what will happen? Copy. If I rotate right now, it should looks like this, right? So while see there it is the box. While I am rotating the box, there is a moment of inertia, a physics term. Like I am rotating the box from uh, here to here. So what can I move? If I move, it may possible this ball moves this way, or this one can just change its position, right? There is a possibility. So in that's why like it's saying like this ball will stay here. It will not move in this other position for this rotation. So this is the one case. Another case is like that's what is said here. Like inertia of the box rotation does not affect the stone's horizontal position. This is what it means. And after that, it is saying guarantee that each stone of the box, each stone of the it is saying like it is guaranteed that like each stone in the box rests on the obstacle or another stone or another or the bottom of the box. So there, what does it means? It means this stone is staying in the bottom. It is allowed. This stone is very just staying in the bottom. It is allowed. But this one, if I take this one and just put it here, this is not allowed. It is not just hang on in the space. It is not possible because gravity only kind of affect the stone. So gravity will fall it down, like just pull it down, and it will comes to this place. So it is not possible. But if there is a one obstacle here, if there is a one obstacle here, then it is possible. Stone can lie on that or above the obstacle. Okay, it is said like that's why it is said like it is the each stone is raised on the obstacle or another stone or any bottom of the boxes. These are the cases. I hope you understand like what are the problem statement means. Okay, let's move to the approach. Before moving to the approach, let's see like let's take a bigger example where every cases get satisfied. Okay, so this is my example. So, and we will also think how could we solve the problem. So, first example this. First example is this one. Let me pull it down a little bit so that I can. This is the first example. So, in this example, what we could see. So, first thing we have to do, we can solve the problem by this manner, or we can rotate the box and solve the problem, right? So, we can simply rotate the box and solve the problem. So, first we have first task will be, and we have to create another. If it is a m cross n matrix, if it is a m cross n matrix, we have to create an n cross m matrix, and we have to return n cross m matrix. Okay, so that's why anyhow we have to take an extra space big n cross m matrix. We have to create it. So you have to take if it is I am considering it's m cross n matrix, I have to create an n cross m matrix. Okay, understand? So let's create that matrix. After that, we fill the matrix. So what I mean to say, I have to create this matrix, right? So I have to create this one, this matrix, big fellow. I'm just minimizing the thing. Yeah. So you have to create. So I will think of the assigning and this assigning of the value later. But for now, I have to create what? I have to create the empty matrix. Okay. Okay. So for that, let me write the pseudocode for that right now. Let's say aim equals to my what is length of the box. It is a box grid. It is saying, right. I am taking as a what is called. I am considering as a box. So my function is nothing but function of rotate box, box, and they pass me one box. I said m cross n matrix. Yeah, hope you understand. So let's say m is what? My length of the box. Okay, so box of my length. What is n? N is nothing but my length of box of 0, box of 0, and that's length. Okay, and as I told you, I have to create, but I have to create one new box. Okay, so new box matrix. So my new box, it will be what? It is a matrix of n cross n. Okay, it is a vector of array list of array list, anything you can write, say n cross n matrix. Okay, so okay, initialize or let me write it this way. Initialize n cross m matrix. Remove this. Just initialize in your own language. Initialize. Wow, what is my spelling? Okay, you can skip this 5 seconds. Initialize m cross n matrix. I'm naming this matrix as what? New box. New box. Fine, as simple as that. Now we have to assign the value. Then we will think of how it will fall or how it works. So assigning the value. So let's see the example. Like for the let's see the what is called this indexes 1 0 1 2 3 4 5 and 6 and 0 1 2 3. So for this is a better example is there. I made a video on this. Let me tell you the what is the name of that. There's actually problem in LeetCode as well. Let me tell you what is the problem name. Okay, problem name is LeetCode 48 rotate image. So my request is please watch a video LeetCode 48 rotate image. Rotate image. In that problem, the same thing you have to do. Like there is a n cross n matrix, and we have to rotate to right rotation. This is nothing but rotation, right rotation, right, clockwise rotation. So it is a right rotation. So this is the thing. So here it is a m cross n matrix. So this is the same logic should be applied. So you can use any video. You can watch any videos on YouTube and come back because if I start explain, it will take me another 10 15 to 20 minutes because I take too much time to explain. So if anyone watch my video earlier, so it is take too much time of video. So otherwise you can do another thing. You can solve this problem rotate image. I have made a video and explain the approach there also, so you can understand the approach from there and come back here. Okay, so my request is like you can watch any video or my video, it doesn't care. Just learn the approach and come back. Okay, so I simply write the formula. So you can just believe me that what I'm writing, that is the formula to just shifting this. Like there is a mapping, like there's a mapping between the index, like this index maps to this index, and this index maps to this part, this index maps to this part. So there is a formula actually. So I'm writing that. If you want to understand, just watch the video. If you don't want to understand, just take this as a formula. Okay, So this is my what my first one is what m cross n matrix, right? So this is my m cross n matrix, and this is what n cross n matrix, n cross m matrix. So what I have to do, I have to iterate from each element from here to here and check which position it goes, right? For that, I'm writing like for I equals to 0, I less than m. Let me write it is a m cross n, and it is n cross m. I less than m, I plus plus. Then for uh, j equals to 0, j less than n, and j plus plus. I'm not using the brackets because it will be a single line of statement and it will take significant amount of space. So let me rewrite the equation, and to assign is what? Assign to the my new array. So new box of j of m minus 1 minus I. This is the formula. This is the mapping. If you want to do, you can do a dry run and you can understand what is the why I'm doing that. I'm not going to explain this part. Sorry. And this is the thing. So this is just to duplicate, like taking the same value here to here. Okay. Let's take that same value. I'm pausing the video and making this copy paste only, because if I don't pause, it will take too much of time. So this is my matrix. Like after I just taken minimize this thing. Like same thing after rotation, the matrix looks like this. Okay. So this is the case. Okay, fine then. So what I have to do right now? So right now I should look into one of the column. I should look into the only one column, then next column. Like now my each like what will happen? It will happen in a single column, right? This column will not interfere the activity of here. This column will not interfere activity of one, or on vice versa. So if I now look into the one column, and it will be good. Okay. So let's understand what will happen. So what actually will happen? This ball is already in right place, right? This ball already in right place. So this ball, let's okay, give an example. This ball already in right place. But taken another example actually. Just a minute. I should have given a different example. Let's create an magic. Okay, not here. Just a minute. I'm sorry. I'm just removing this one to here. You'll understand better later. So this example I've created so that we get all the outcomes. Okay. So okay, now and okay, this now there is a problem because this cannot rest on the what is it is called on above or in the what is called cannot rest, and this cannot hang on the air. So what should I do? Okay, let me come back just a minute. Okay, I have made some small changes so that we can get all the possible kind of conditions or scenarios. Okay, so for example, so forget our other things. So this is my box so given here, and this is my what is called this like new outcome. Like after rotation it looks like this, but this thing is not my outcome. This is very unstable because now the gravity will affect. Okay, so every ball will come down, and whatever we see, what will happen. Okay, so for now what we can assume, like we can consider each and every place and will happen. We check what will happen in this place, in this place, in this one, in this place. Okay, so as I told earlier, like we have to now check column wise because each column has is like it's a separate sub problem. Each column is a separate sub problem. Okay, so each column we don't have to check. If I check this column, we don't have to check what are the other balls or box or obstacles are doing. We don't need to check that. We can just focus on this column, and I will see like what will happen after gravity just affects the ball. Okay. Okay. Let's see now. Discuss on the our outcome. So what happened? So we have to check. We'll start from here. We'll start from the bottom and check what will happen. And if it is right place, if it is right place, if it is right place, what will happen in this place, in this place, in this, in this place. Okay. So let's start. So my currently my I will start from, as I said, I start from the bottom like J, and also I need one variable to see the bottom. Okay. So that I can understand what is my last position, like last position. Because see what, why I am taking this bottom variable, because at the end this ball will have to go to some place, right? So it has to go like this ball is already correct position because it is already in this corner. Now this ball have to go in this place, right? So I need a place, my j, when my j will be here, I am checking this ball, right? This ball now go to this place. For which place I have to go, I have to also find out one space, like one cell, like in this cell it should go. So that's why I'm taking one variable bottom. So both of I will initialize the below. You understand why I'm both initializing at the below. So what happened here? So what I can see, if I can see like this ball will, what will happen? This ball will stay already in correct position. So what I will do, like I will check. So what are the cases? Cases are, I can first case, what I can get an empty space, and which is denoted as dot, empty space. I can get another ball in the array. It is in the, what is called, in the input it is given as thing like stone or balls, and another thing I can get an obstacle. So this is the obstacle. I can get any three obstacles. So what happens if we get a ball first? So if I get a ball, if I get a ball here, so a ball or of stone, I'm saying is ball, so please I'll settle it's a ball. So this is a ball. So ball, we have to say if if it is in correct place or it will fall below. Okay, we have to check that if it is in correct space or it will fall to the below. So we have to check also that. Okay. Okay. So for that, okay, again I have to check one thing, change one thing. This is not a good example. Why I am not getting a good example? Okay, I am changing another position. I can see. So this is what. Okay. So if that is the case, okay. So if it is so I have to check whether it can fall or down or it can stay. It can fall down or it can stay, right? So for an example, let's start deducting the problem from second column. You'll understand why I am saying this second column is starting from second column. As I told you, it doesn't matter we start from like which column we do. Like this is separate column, this is also a separate column, and this is also a separate column, right? So each column doesn't intervene the process of another column. So for the, so that you can understand easily, I am starting with the second column because this is the special case, and this is the general case. Okay, this is the general case. Why I can't do this make as a second column, first column? This is because if I have to, if I pass same thing is this uh, first column, if I do that, it is not possible. See here, like it is mentioned like the ball cannot be rested on the, if I see this, if I put this thing in here, these two ball will hang above, right? The ball will hang above and this is empty. So that time this ball is hanging without, it is without anything, like it cannot, it is not possible. In the question it is not possible. The ball should rest on the ball or on the bottom or any obstacle. Okay. So there's the reason. There's the reason I have to make it as a second row, or sorry, second in this is third row. So here it becomes second column. So what? So let's start with the second column. Let's understand the process. Then even it will be easy to understand actually. I have already wasted 10 minutes to saying this kind of things, useless things, whatever. This is my thing. So this is my J right now. This is my J right now, and this is my bottom. So bottom is this B. See, it looks like F. Everything is bad. Okay, this is J problem, and this is bottom. Okay, why I'm saying that or not? This is not a J. Why I'm doing this kind of thing? I can't edit as well. Okay, this is J and this is bottom. Both are starting with the negative places. So what if I get one empty cell? So if I get an empty cell right now, one for some time, so this will be empty, right? This column may be entirely empty. This column may be entirely empty. It could have balls empty. If it is empty, I will simply do what? I will simply increase the value of j. Like j will point next one. J will point next one. Okay. So again, I can say this is empty. So I will do what? Again, j will go to the pointing the next one, this one. Again, it is empty. Again, it will go point to the next one. So this is how it will comes to this place. Okay, one by one step. Now, whenever after that, what will happen? After that, j it is that was also empty. Then j comes here. So here I can see the ball is there. So ball is there. Now we have to do what? I have to put that ball into the bottom place at the one place. So there's the reason I am pointing the bottom. There's the reason I am pointing the bottom. So there's the reason this ball will comes here. Okay. So this will come here. So after that I will make this ball will appear here. I will make this one as empty because see ball whenever a ball will come here, this place will becomes empty, right? So that's what I have to do. Okay. So if I write that code for you, what I am saying is I am writing the same part. I'll organize the code later. For an example, what I am saying, if my new box and I told you, we have to iterate through column wise. Let's do that. So let me write at least the basic part. So otherwise it will be very tough to understand. It's already small. Not I will not say it's a hard problem, but still. So for I am saying what for the start from it's n cross n matrix, and I have to iterate to each column. So for I am saying is a column for column equals to it is a 0 and it will be column less than m because it is n cross m. So less than I am iterating to column. So column plus plus. Okay. So now what I am doing after that, I will initialize as I told you. I initialize the value. I will initialize the value of two things. One is my bottom. So bottom is equals to what? Equals to m minus 1. Sorry, it is not m, n minus 1. So it is a n row, right? So n and cross m. So it is n row, n minus 1. And, and again my j will what? J also my n minus 1. So now what I have to do, what I told you, what I have to do, I starting from j from here to here, right? So while while my j is greater or equals to 0, I have to do something, and after each cases I have to do j minus minus. Okay, so these three step we can do using a for loop. Like see here, for each and every time I have to check iterate one element, one cell like this way. So I can, instead of j in a while loop, I can simply do j as a for loop, right? So I can write for j equals to n minus 1. It will like when it will be j less equals to, sorry, greater equals to, until j less equals to 0 and j minus minus. I'll do that. Okay, so this is what I will do. Now let's write the code. Now what if I told you what is my, it is a blank position. Like I told you, it's a blank position. So whenever I am getting, so initially J is where? J is this position. J is this position. So when it is also blank, so what I have to do? Whenever I am getting blank, I am doing nothing, right? So whenever I am getting blank, so if my new box of my J and my current column is what? Is equals to empty. Nothing is there. Blank space. This is empty. Yeah, nothing is there. What I have to do? I will just say continue. Continue. Because I don't have to do anything. I have to just continue. Like I have to go to the next place. Next place. Like it will be J will be decreased and J will come will be decreased and J come in this place. This is how it will work. I guess you understand. You are able to understand actually. So this J comes here. J will come here. Now again J is empty. J will again decrease. J will come here. Then J again empty. J is come here. J again empty. J is come here. I guess you understand. After that, J will again empty. J will come in this place. Okay. I guess you get it. J will come this place. So at this place, there is a ball. There is a ball or stone. So here what will happen whenever I am getting a ball, so my bottom I am not increasing. So bottom is still in the bottom because it is already a bottom. It's a bottom actually denotes the at the last cell what is the valid one. So if it is already a bottom, okay, it is a bottom one. So this ball should come in this bottom place. I guess you understand. This ball should come into this bottom place. So what I will do? So my next statement will be I'll check again this one. Copy and paste. So else if my my this one is a stone or a ball. What is the final thing? If this is the case, then I have to do what? I have to just put the thing like my bottom should be my ball. Okay. So my bottom. So new column, new box of bottom and column. This will be what? This will be my this one, this surf. And after that, what I have to do? I have to do bottom is now filled because this is become the ball. This becomes the balls, and this should be an empty. Right now, it falls down. So right. So this is the ball, and what I have to do? Another thing. I have to do what? I have to that place is now becomes empty, right? So new box of bottom and column, this becomes my empty. Okay, it becomes empty. And another thing I have to do, I have to reduce the bottom. So bottom is right now bottom minus minus. Okay, bottom minus minus. So I guess you understand why it is this, because right now the ball is comes to in this place. Now bottom should point this place. Bottom should point this place. Okay, we'll see all other cases. All other cases should be understand what will happen. So again, after that, this J is over. Now J will point to this place. Now J will point to this place. So there is another ball. Again, the same thing will occur. Like now it will go where it is bottom and column. So it will comes to bottom places. Here it will ball will come here. This ball will appear here. After that, we'll do what? We'll clear, like this ball will be cleared from here. So it is done, and bottom will now come in its place. Bottom will now come to this place. Bottom will come to this place. And after that, J will also go out of the loop because J will denote here. So this is out of the loop. So this is done. This row is now my sorted. This row is now my sorted. So why I told you like I should come to this row later. Logic will be the same, but why should I come later? So you can understand right now why this I am coming this part later. So what I will do here. So again my bottom will span down here and J will here stand so like pointing the very last cell. Okay, very last cell of the column. So right now what again I will do? I will do what? So again the thing is now see what. So I am checking is it my current positions like J and column is a stone or ball or not. Yes, it is a ball. So I told it what. So new max is bottom and column. So do the assign. So it is already there. The bottom and column is give us like same thing like bottom and column give us like it will point as stone is stone. Now what I am doing here, see my bottom and okay, not bottom and column, it was my J and column, J and column. Okay, J and so I'm doing is J and column is I'm marking this thing as empty cell, right? J and column I'm marking this as empty cell. See now there is a problem. J and J and this ball is actually in the same position. J and this ball actually in the same position already. So if I do this thing, then what will happen? It will kind of let's remove this ball. Simply it will just remove this ball. So that time it will be a problem. That time it will be a problem. It will simply remove this. I can't remove this ball. So before I assign this thing the value, I have to just check this bottom and J value should not be equal. This bottom and J value should not be equal. So I will simply write one condition here. Simply write one condition here. If my bottom if my bottom is not equals to my jth value, so then only I can write the following condition. This following condition. I hope you understand why this is the case, and this is the reason I told you I will come the first column later. I did the second column earlier. Okay. So after that again what bottom will also come here like bottom will decrease the value. So bottom will come here. J will also change. J will also come here. J will also come here. So in this case, again we can see like again we can see J will loop here. We'll check it is a ball. Okay, it's a ball. So I'm assigning new bottom of that bottom value of the same column as a ball, marking as a ball. Okay, like ball will come in this place. After that again I'm checking if bottom is not equals to J, but here bottom is again equals to J. So I will not do this part. I will not making the J as an empty space. So I will simply move the bottom and this decrease the value of bottom. Okay, and also J will come to in this place. Now J will come this place. Now J will empty, it will come here. See, I don't have to do anything, I have to continue. So it will just simply come and this place again. J is empty there, so J will again come here. It is again empty, then J will come in this place. Okay, I guess you guys are getting the this is the my intuition why it is happening. So now the thing is there is a ball, there is a ball, fine. So there is a ball. So what happens again the problem is comes here, like if there is a ball, then what, then it will come here, ball. So it will say new bottom of columns. Now bottom is pointing this position. So this ball, I can mark this thing as a ball, mark this one as a ball, and empty this thing because here right now this place and bottom place is different. So I can empty this position. So I'm empty at this position. After that, bottom will again point to the new part, this one. Bottom will decrease its value and will comes to this place. But j will also decrease its value and comes to this place. Similarly, same thing will happen with this ball. This ball will come from that place to this place. This place to this place. So j, right after that, j will go outside of that loop. This is the end. And also for actual cases, bottom will also come in this place, and after that j will go out of the loop. It's done. Okay, hope you guys get it. Now till now I don't get any obstacle part. Okay, I don't involve any obstacle part. Now we will come to the obstacle part. Okay, so again initially my bottom will point to this part and j will point to this part only. Again this is empty, like uh, this is place is empty, so j will continue, sorry, j will continue, like j will come to next place, bottom will stay in the same place. It is the place. Again it is, sorry, not that place, this place. Again it is empty, and it is empty that because it will come in this place. Now see what, now j is now see what, now j is getting one obstacle. Now j, in the jth position, I'm getting an obstacle. If obstacle is there, now I can't change obstacle's position, I can't touch obstacle. Okay, so I'll simply do what, my now bottom cannot be here, because if there is any ball, so assume if there is any ball, assume this obstacle is not there, if there is any ball, this ball should right now come in this place, not in the obstacle's place, like just before, just above the obstacle. The ball will come just above the obstacle. I guess you get it. The ball will come just above the obstacle, right? So there's the reason I will do what, if I get any obstacle, I will mark these as I just simply change the bottom's position. Bottom will now point to the obstacle minus one's place, like they're just above the obstacle. That's why I said, like like because this obstacle I can't touch. So what I said, like if it is an obstacles, I'll same copy this part, copy and paste. If it is an obstacle, then I will simply do bottom minus minus. Like we will also see, like is it sufficient or we have to do any other stuff, we'll see later. But for now we will do bottom minus minus, sorry, bottom not minus minus, bottom equals to obstacles position. So obstacles position is currently new j column, uh, column minus 1, so it will be, or jth position, so j minus 1, because bottom is what, obstacles position is where, obstacle is currently pointing the wherever the j is, obstacle is there, it will point to the j minus 1. So bottom will go and point the j minus 1. I hope you get it. For now this is the case. Okay, for now this is the case. Okay, I guess you can also see, I can want to maximize, this is fine, I guess. Yeah, this is fine. So okay, so what I'm saying is now bottom will point j minus 1. Good, will come here. Now again this j will not here, j will do what, j will come in this place. Here j is empty, so simply when j is empty, I'm simply continue. I'm saying is continue, don't do anything, continue. Then now j will come here. Again it's a bottom, sorry, it's an obstacle. Again I told you, whenever I got the bottom, I will point my bottom to j minus 1. So this j, this bottom will go to j minus 1. It will point to this place. Correct? Okay, let's remove my some place bottom and j. So my bottom will right now point in this place. Now j is right now here. Correct? Now j will also just go above. It will come here. It is again, see, j is getting, j is empty. So again j will do what? J will also move to above. J. Now J is here. Now you can see what? Now you can see like here is a ball. So if there is a ball, so again we can see the same thing. The ball is there. We have to move the ball there. I have to check whether this ball and bottom place is same or not. If it is not same, then we can remove it. So what I said, like we initialize the ball at the bottom place. So initialize and not removing first, and initialize the ball in the bottom place. Initialize it. I'm checking is J and bottom are same. No, they are not same. So what I'm doing, I'm removing the Jth position ball from the, I'm removing the ball from the Jth position. Now what will do happen? This ball will come. Sorry, bottom will come point to. It will move above one top places. So after that, J will go to out of the index. Like J will complete the loop. It's fine. So now again, let's go and see the last column. And do we like we have to see like do we have to change any code or anything or not? So we have to do what now? Again J and bottom. J and bottom. Right now both will point. Okay, let's write point it from here. It will be easy. Like bottom and J. Just remove. Okay. Right, bottom is here and J will be also there. So right now both pointing my bottom. Both pointing the last cell actually. Last cell of the column. So again, J in the J position, we got an obstacle. What I told you, whenever we got an obstacle, we will just just bottom will move one place above. So bottom will move in this above position in this place. Okay, so that's all. Now J will also move. J will also move. J will also come in this place. Here it is getting again. It is getting one obstacle. If it is getting obstacle, simply I have to just uh, move the bottom's position. Bottoms is now pointing here. Now J will also point moves to above position. It is getting here. Now it is getting what? This is getting a ball. This is getting a ball. So what is the logic of the ball? Whenever I got to see a ball, I will assign the ball at the bottom place. So it is already assigned. So even though I'm assigning the ball in this, you can see I'm assigning the ball in this place. Now I'm saying if J and bottom is not same, then I will remove the ball from J's position. But see here, it is same here. So it is same here. So I don't have to remove anything. So I will not remove. So what will happen here? It will now what will happen? Now bottom will point to the one cell above. Bottom will point to the one cell above here, right? Now J will also go one cell above. J will also go to the one cell above. J will coming here. It is an empty cell. So empty cell, what do we do? We do nothing. We will move to the next cell. So we come to the next cell. There is a ball. So whenever I get a ball, we assign the ball in the bottom's place. I am assigning the ball in the bottom's place. Okay. After that, if my J and bottom are not in the same position, then I will remove the ball. I will remove the ball. Okay. I did that. After that, what I will do? I will simply uh, move the bottom one place above. Now, in the next iteration, J will also move one place above, right? J will also come this place. See here, what I am getting? I am getting an obstacle. Again, I getting an obstacle. Okay. So what I told you, whenever we get an obstacle, we will simply move our bottom on top of the obstacle, right? This is what we will do. After that, J will also go to that place, and this is empty. Fine. So J will again move, and J becomes out of the loop. So what we see, whenever we get an obstacle, we don't need to do anything. We can just remove the button. So this is actually whole code. This is the actually whole code. I guess you understand. This is the logic behind it. Simply you have to just visualize the problem. Every time you get this kind of question, just simple loop. Nothing else is there. No logic, nothing. Nothing that much of logic is there. Just have to visualize what are the conditions. See, there is a loop and normal simple if else, if else, if else statement. Basic if else statement problem it is. So this is what. And another thing, see this thing. If it is a continue, do I have to write that thing continue? No, right? So it is after you can write or you can remove. So for you, I am just leave it because it is actually giving you can understand like otherwise you will think like where this this condition goes like whenever we get our empty, what will happen. You don't understand. This could be possibility. So I'm removing, not removing, I'm leaving this. So if you wish, you can remove this continue because it doesn't create anything. You can directly check if from second and third cases. So this is what it is. So let me finish. This is the for loop, and that thing is above for loop also ends. So at the end, I will return new grid. I guess you understand the problem. So let me also position this thing correctly. This thing will come here. This thing will